In this tutorial, we are going to see this code of insertion and deletion which we have discussed in previous tutorials. So let's see. I have created this main underscore head as a global variable and which is the head of linked list. Okay. Now these are the function for insertion at the beginning, insertion after a given node, insertion at the end, and this is the function for traversing. This is the function for deleting from the start or beginning, delete after a given node, delete from the end. So this all functions we did discussed in last tutorials. If you haven't watched those videos, then go and watch those videos. Link is given in the description below. Now let's try implementing these functions. So first we need to create a linked list. So we need to insert the node. For inserting, I am using beginning function at the first. So let's use beginning, and I am inserting 3 at the beginning, and I am printing this linked list using this print list, or you can say a traverse function, and I am passing this head of my linked list, main head of this linked list. Now let's see. So we get this 3 printed. That means our linked list is consisting of one node, that is 3. Now let's try inserting at the end. Insert at the end, and let's insert 10 into it. Okay, now let's try printing this. Okay, you can see 3 at the beginning, then 10 at the end. Now let's try printing after this 3. That means insert after this 3. Okay, so this 3 is our first node, and whose address is in main head. Okay, so I'll just write insert after this main head, that means this third node next. Okay, so it will insert after this 10. Okay, and if you want to insert after this 3, just write main head here. Okay, let's see both things here. So I'm inserting 4 after this 3, and also I'm inserting main heads next 11 to this. Let's print. Okay, so let's see. So we get 4. That means we inserted the node after this main head or first node, and we inserted the node after this main heads next, that is after the second node. We get 11 here. Okay, now let's see. Okay, now we need to delete a node from it. For that I am using delete start. So I'll use delete start, and I'll print the linked list. Okay, so it will delete 3 from the starting. You can see 3 is deleted now. Now let's try delete from the end. Okay, okay, now let's try running the code, and you can see. Okay, so delete end is not working. Okay, so okay, so delete end. Now let's try running this. You can see 10 is deleted from here. Now let's insert some more nodes, insert nodes after insert at the end. So inserting more nodes here, 11, 12. Okay, now let's see, we need to delete after, and we need to delete after this main head. Okay, let's try printing this linked list. Okay, so you can see 11 is inserted, 12 is inserted, and the node after this main head, that is 11, is deleted. Okay, now let's see, what if there are 5 or 10 or so many nodes and you need to delete the 10th node, or like let's say 6th node. That means if you are given the position of a node, how you reach that node? Let's see, let's first insert some more nodes into it. Okay, so I'm inserting 13, 14, 15 and 16. Let's insert some more, 17, 18. Okay, now deleting this 6th node. Okay, so I'm using while loop and I'm initializing a count variable to 1, and I'll keep incrementing count and keep shifting this temp to temp next. Okay, now see, we need to delete the 6th node. That means we need to get this address of 6th node. For that, we need to keep looping until the 5th node, and from the 5th node's next part we will get the address of 6th node, right? So I'll write count less than 5. That means if you count up to the 5 nodes and you reach temp to the 5th node, then just stop looping, delete after this temp. Okay, so let's see. Okay, let's try printing this. Okay, let's see. So we're facing the error here. Okay, we haven't initialized the temp here. So write node pointer temp and initialize it to main underscore head. Okay, fine. Let's try running, and we get 15 deleted. You can see here 1, 2, 3, 4, 5 and 6. 15 is our 6th node and 15 is deleted from this position. Now if we again delete the node from the 6th position, it will delete the 16. Let's try doing it. Okay, so I'm again deleting and again printing the list. You can see 16 is deleted from this position. So this is how we delete the node from the given position. Okay, also you need to delete the node whose pointer or address is given to you. Let's take an example. Let's say this is the linked list and you need to delete this particular node. Now you know the address of this node, but you don't have access to the previous node. Basically, in deletion, what we does is we reach to the previous node and we find the address of this next node and then replace this part, that is previous node's next part, to this node, right? And we delete this node. But in this case we don't have access to the previous node. We have just address of this node which we want to delete. Now one method is to delete this node is you can loop until this address of this node and you can keep track of this previous node, and thus you will have a complexity of on. But let's try doing this in complexity of o1. Let's say this is the node you want to delete, and now what is the approach is, you just need to shift the data of this node to this node. Let's say this is having 3 as data part and this is having 4 as data part. Now shift the data and next of this node to this node and delete this node. Easy, right? I'm repeating it again. You just need to shift the data of this node, data and the next part of this node to this node, and instead of deleting this node, just delete this node, right? Let's try doing this approach. So for that, what we need is, we need to create a temp pointer which we have already, and we need to create a pointer named, let's say, node delete. Okay, now you need to write delete equals to temp next. I'm storing the address of this node. I'm storing this 4 node into this del pointer, I mean address of this node into del. Okay, so now store temp equals to del's data. That means we are storing 4 into this location here, right? Then I'll again shift temps next equal to temps also. I'll shift the address of this node to this node. Okay, let's write data here. Okay, fine. Now I need to free the address of this node, so I'll just write free del, right? And yeah, here we get this. So let's try printing the linked list. If we get that node deleted, that means we need to we are going to delete this 14th node. Okay, let's check if there is any error. Yeah, let's try running this. So yes, 14th node is deleted, you can see. So this is how we can access, or we can delete the node just one time. There can be several possible cases of deletion and insertion. You may practice insertion after the second occurrence of that element. That means if you have 11 at the repeated positions, then let's say you have 2 11s and you need to insert the node after the second 11, not after this first 11. Try this approach by yourself. Also, you can try insertion of a node after the particular position given, let's say after the 7th node. Okay, so that's all for this tutorial. Thanks for watching. If you like the video, then like, share and subscribe.